So thank you again for reminding me to record this lecture. All right, so let's continue. What is the answer for this exercise? Dx, dy, and also the tension, and also the moment. Anyone? I believe you already done it. Anyone? What is the answer? What do you get? Buat ke tak buat ni?
Tak buat, Doktor.
Tak buat. Raya kan, makan biskut raya.
Betul, Doktor.
Betul. Is there anyone got the answer? No one. No one. No one. Okay. If not yet, if you don't have the answer yet, I think we have to discuss it now. Okay, because this is really important for you. Okay. Let me draw again the FBD. Okay, the FBD will be look like this. Okay, we do have A, B, oops, C, and D. Okay, and then we do have a force at A, which is tension. C also tension. And D, we do have dy, dx, and moment. Moment at point D. Okay. And then at B, we do have external forces, which is 150 Newton. Okay, right. Okay, so let's do together. Can you tell me what is the angle for this theta 1 and angle for this theta 2? Okay. Can someone calculate for me? This theta 1. Oops. Okay, it should be this one 0.36, is it? And this 0.15. What is the value for theta 1? Please, someone.
22.6, Doctor.
22.6. Okay. How about theta 2?
36.9.
36.9. Okay. Right. Okay, for to others, please check the answer for the theta 1 and theta 2. Is it same or not?
Same, Doktor.
Okay, great. So what's next? Once you have this complete FBD, then what is the next step that you should do? What is the next?
No dimensions.
Yes, correct. So we have to put the dimension. Let me do something here. Okay, give me some time to do something. Okay. Okay, let me draw again FBD here. A, B, C, and D. Okay. Then we do have the tension at E, tension at B, reaction at D, force at B. Okay. So theta here, 22.6. 36.9. Okay. And also the last one is the dimension, which is 0.08 and 0.2. Okay, let me check. Is it correct or not? Yes. Okay, if wrong, please say to me, okay? All right. So once you have this FBD, what is the next step? Can someone tell me what is the next step? Yes, Maria said the equilibrium. Which one you want to choose first? Is it equilibrium for Fx, Fy, or moment? Yeah, the answer is correct. So you have to calculate, you have to use the equilibrium system for the moment first, and you will get straightforward the answer of T, tension. Okay, so we are taking moment about point D, okay, and it should be, oops, it should be equal to 0. Okay. Okay. So what is the equation for this moment? Okay, let's say I assume clockwise is positive. Okay. So can someone tell me what is the equation for this moment? Someone, 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 someone.
Negative 150 times 0.28.
Okay. Next. Someone. Next. Siapa ni? Ainu Syuhada dia. Okay, what is
Yes,
the...
sir. Yes, sir.
Oh, okay. Thank you. Okay, next. Next. Oh, ada tulis. Okay, plus T sine 36.9 times with 0.2. Yes, correct. Plus T sine 22.6 times 0.36. Yes, correct. Yes. Meaning that you already understand the way on how to calculate moment. Okay. So 0.2 and plus T sine 22.6. Let me use this value. Okay, I erase this one. Okay, 0.36 equal to 0. Okay, so what is the final answer for the T? Final answer for the T. Yeah, T equal to 162.5 Okay, easy, right? Bak kata orang Melayu celah gigi je lah, celah gigi kan. Senang je kan. So, okay, this is the answer for T. Okay, right. Okay, once you have the T value there, okay, you can use equilibrium system for X and X for X and also Y component. Okay, let's say X is positive for the right side. Okay. And then you will get dx later on. Okay, you will get dx later on, dx. Okay. Plus t cos 22.6. Okay. Plus t cos 36.9 equal to 0, right? Please check, please check. If wrong, please tell me. Okay, so the value of t that you will get in the beginning, you can substitute into the equation. This one, you substitute into the equation, you will get t straightforward. What is the value for t? Sorry, t pula, dx. What is the value for dx? What is the value for dx? What is the value for dx? Minus 280 Newton. So everyone please check. Okay, so you get dx. And then if you use the equilibrium system for y component, you will get dy later on. Okay. Sorry, yeah. Okay. Okay, sorry about that. Let me do something with my laptop. Okay, let's continue. So upward is positive. Okay, so we do have t sine 22.6. Sorry, something wrong with my laptop. Okay, minus 150 plus t sine, sorry, again my laptop got problem. I will fix it after this. Plus dy, okay, equal to 0. So anyone please tell me the answer for dy?
Minus 10.
Sorry?
Minus 10.
Minus 10. Okay, so this is your answer. Okay, this is your answer. Oops. Okay, this is your answer. All right. So Please give me 5 minutes to fix my laptop. I have to do something with my laptop because there are many error, not many error, many problem, technical problem on my laptop. So give me 5 minutes to fix it. Okay, I'm done. So let's continue. Okay, let's continue. Okay, so far any question for this exercise? Is there any question from you? Before I proceed to the next lecture. Any question? No question, right? Easy, right? Huh? Okay, so far no. Okay, great. So let me continue. Okay, so let's continue to this lecture, which is we call it two force member. Okay, two force member. Why you need to learn this two force member is because some cases, okay, you have to introduce something. Okay, you have to introduce some forces. Okay, because the first thing is because the complexity. Okay, if the system is very complex, meaning that you cannot solve manually, you cannot solve very I mean you cannot solve it in the same way that we did just now. Okay, because the complexity. Okay, number two, since the system is complex, then maybe the system will have more than 3 unknowns. Okay, maybe the system have more than 3 unknowns. Okay, if let's say the system having 4 unknowns, meaning that you have to determine, you have to construct, you have to write 4 equation at least. Okay, 4 equation. So 1 unknown give 1 equation, 2 unknown give 2 equation. Okay, 3 unknown give 3 equation, and 4 unknown give 4 equation. So if you have the system that require you to use 4 equation, it will be tedious work. It will be tedious work. Okay, that's why we learn these two force member to tackle these two issue: complexity and also the number of unknown. If the number of unknown is more than 3, okay. All right, two force member. Okay, definition. What is the definition for the two force member? Okay, a rigid body of negligible mass with only two forces acting on it. Okay, so in the single rigid body, okay, the two force member, meaning that there are only two forces that acting on the rigid body. Okay, that's why we call it two forces only. So there are only two forces that acting on it. Okay, no other forces that acting. Let's say we do have this AB rigid body lah, the simple one, okay, the simple one. We do have this rigid body with no forces yet, okay, with no forces yet, okay. Back to the fundamental, back to the knowledge that you have already know previously for the equilibrium system, okay. Every single forces like moment, like forces, okay, must be equal to zero. Okay, the summation of forces, the summation of moment must be equal to zero. Okay, must be equal to zero. Okay, so let's say we are taking moment about point A. Okay, let's say we are taking moment about point A here. Okay, so you have to calculate moment lah using M equal to FD. Okay, for 2D. Okay, so if you want to make sure that this system is in equilibrium, okay, you must understand, you must introduce the forces that make the system in equilibrium system. Okay, so let's say we are taking moment about point E. Okay, in order to make sure that the system is equilibrium, make sure that either one is equal to zero, either one must equal to zero. Okay, either one must be equal to zero because we want to make sure that the moment must be equal to zero. Okay, all right. So in order to determine that, so because we are taking moment about point E, the one that we choose for the force must be from, okay, must be from B, either this way, okay, force, this way, force, okay, because we are taking moment about point A. Okay, so I believe that you already understand about the moment. Okay, so we know that the force must be acting on point B. Okay, point B. Okay, and to make sure that we do have moment equal to zero, okay, we have to make sure that either one must be equal to zero. In this case, because we do have the force, okay, which is the magnitude is there, but the magnitude of F is there, meaning that this one not will be equal to zero. So the thing that must be equal to zero is D. Okay, D, the perpendicular distance. Okay, so in that case, actually straightforward, the D value that gives zero to the moment is actually must be parallel to A point. Okay, this one. Okay, this line. This one should be D lah. D. And this must be equal to zero lah. Okay, this must be equal to zero. So for moment about point A equal to zero, the force at B must act along the line AB. Okay, the force that I introduced earlier, okay, like this, like that, okay, the force, okay, must be along the line AB. So along the line AB is the dotted line that I just draw just now. Okay, this one, F. So once you have this F, that there is no perpendicular distance to point E, meaning that your moment is equal to zero. Okay, because the perpendicular distance must be equal to zero. Okay, the F must be at along the line AB. Okay, all right. So once you have this, we know that M must be equal to zero lah. Okay, all right. For that one is for point A. If let's say we are choosing point B to calculate the moment, okay, to calculate the moment here, point B, Okay, so we have to consider forces that acting at point A. Okay, this one is the possible forces lah, possible forces, and not the final yet, not the final one yet. Okay, so moment about point B should be equal to 0, and of course we are considering F, and we have to determine the D, that there is no value for D lah, must be equal to 0. So same goes to MA, where the force, okay, where the force must be at along the line AB here. Okay, okay, must be at like this force. Okay, then we will get moment about point B is equal to 0. Okay, so for this one is actually example. Okay, you can do this way as well. You can do the forces in this way, the opposite way. Okay, like this, like this. It is also giving moment equal to 0. Okay, it is also giving moment equal to 0. Okay, okay, so therefore the two forces must act along the line AB. Okay, since you have introduced this force, okay, to make sure that this system is in equilibrium, you have to cancel out the force that you introduce. Okay, let's say this one that I introduced. Okay, to cancel again this system, to return its original rigid body, where there is no moment, there is no forces. Okay, we have to make sure that we introduce another force like this. Okay, so this one, this force and this force is cancel each other to get the initial rigid body like this. Okay, with no forces, with no moment acting on the rigid body. Okay, all right, so therefore two forces must act along the line B. Okay, so there is the two forces that you introduce, okay, to simplify the calculation later on. Okay, I will show you the example. Okay, all right, so before the question, okay, let me continue about the forces, the component. Okay, all right, just now I explained you about the moment. This time I will explain you about the equilibrium system for the forces. Okay, we know that summation of forces must be equal to 0, meaning that the system will be in equilibrium. Okay, so for summation of forces AB, the magnitude, like I said just now, the magnitude that acting B and A must be equal. Okay, let's say this one is 100, this one should be 100 as well. Okay, the magnitude of force, okay, at A must be equal to magnitude of force at B. Okay, and the direction, as I mentioned just now in the previous slide, the direction must be opposed to that of B. Okay, let's say I doing this way, which is tension, tension. Okay, the point will be going for the A will be going this way, for the B will be going this way. Okay, let's say I'm doing another way. Okay, I introduce a force at point A. Okay, this way, like this way. This is the line of AB. Okay, this way. Okay, the other force that acting point B must be opposite. Must be opposite like this. Okay, so to cancel each other. Okay, this is a basic Newton first law. Okay, basic Newton first law. Okay, so before I proceed to the example, is there any question? Okay, let me continue before we do have the example. Okay, since from the explanation just now, there are two possibilities of the two force member. Okay, either the body in tension or the body in compression. Okay, the left part showing you the body in tension where the forces is going out from the rigid body. Okay, and the right part where the body in compression, where the forces is acting towards the body. Okay, it compress, the force compress the body. Okay, so there are two ways you can use either one, depend on the situation, depend on the understanding, depend on your preferable. Okay, therefore for a two force member, the two forces must have the same magnitude. Okay, this one, as I mentioned just now, the force, this one should have a same magnitude. Let's say 100 Newton. This one is 100 Newton as well. Okay, same line of action, must be same line of action. Okay, to make sure that this system is in equilibrium in terms of moment and also forces. Okay, if the force is not same line, meaning that we not follow this element, we not follow this equilibrium system. Okay, and also the forces must be opposite sense. Okay, all right, so any questions so far? Do you understand?
Yes, Doctor.
Okay, so I believe that for the lecture note there is no problem. You can understand straightforward, but when you do the exercise, you will see there are many questions that you will ask later on. Okay, let's continue this one. Okay, so this is the exercise one, which is will explain or will utilize the two force member. Okay, will explain the two force member condition. Okay. Okay, the question asking you to find the reaction E at E and B and D of the rigid body. Okay, we do have two points there, A and D, that having reaction. Okay, that having reaction. Okay, all right. So again, my question is, what is the first step that you have to do? What is the first step that you have to do? Sharifah left the meeting. What is the first step that you have to do? Someone? Okay, great. So make sure that the first step that you will do, you should do is draw FBD. Okay, so based on my experience from the previous student, they did not draw FBD in the final answer for the test and also final exam. Okay, so make sure that you draw every single FBD. Okay, I believe that someone can imagine the FBD without drawing. Okay, but this is the necessary thing that you have to do during the examination, not only examination, but during the practical work later on in industry. Okay, okay, the first thing that you have to do is to draw FBD. Okay, so which rigid body that you want to draw? Okay, this is a bit tricky. Which rigid body that you want to draw? Okay, there are two rigid body there, A, B, C, and also B, D. Okay, A, B, C that connected B, D at point B. Okay, so we do have two rigid body. Which one you want to draw? Which one you want to draw?
BD.
B, D, B, D. Ada jawapan eh? Okay, never mind. BD? No, no. BD, no. The answer is no.
Yes. Let's see.
You cannot draw. Let me explain about this one first. You cannot draw only BD because there is one known value in the system, which is at point C. Okay, which is at point C. So if you draw BD, you don't have any known value to solve the problem. Okay, this is the tricky one. This is the step. This is the important element that you have to understand. Okay, to draw FBD, make sure that the known value is there, so you can solve the problem. If no known value, then you cannot solve the problem. Okay, so okay, Simbiki, yes, the answer is all. Okay, you have to draw all. Okay, you have to draw all. Okay, why all? Okay, the basic thing that normally I do, okay, I have to identify, we need to identify the rigid body that useful for the calculation. Okay, let's say the student just now said that we have to draw BD. So I can see that the BD, there is no non-value. Okay, let's say I draw ABC. Okay, the non-value is there. The non-value is there, but you will have 4 unknowns. Okay, you will have 4 unknowns, and the 4 unknowns will give more tedious work to you later on. Okay, because you are calculating non-value that not necessarily to be calculated in this example. Okay, let's say I draw ABC lah, ABC to make a better explanation. A, B, C. Okay, let's say you draw FBC. Of course, BD cannot lah. You don't have the known value there. Okay, okay, never mind. I just explain. Okay, never mind. I just explain it. Okay, BD. Okay, you don't have known value there. You only have BY, BX. Okay, this one DY and DX. Okay, so this one cannot, because all of them are unknown value. You cannot solve it. Okay, about ABC, okay, ABC, this one AY, X, okay, at point B, we do have pin system as well, BY and BX. And point C, we do have the known value. Okay, if you think to draw ABC, yes, you can, but it will be tedious work later on, because we're not calculating this one, BY, BX. The question asking you to find A and D. Okay, so the best FBD for this system, for this example, is that you draw the all system, where you exclude the wall here and also the socket here. Okay, because in the end of the day, you will straightforward get the answer. Okay, this one is not necessary. This one is not necessary to be calculated. You can use this ABC. Okay, you can use this ABC, but again, the calculation will be tedious and long calculation will be done. Okay, so the easiest way to avoid many calculation, the easiest way is that you draw the all one. Okay, this one. Okay. Okay, you draw all one, and then you determine the known value, the reaction. dx. Okay, and then D is 100 Newton. Okay, so if you use the third FBD, let me call this one third FBD, this one second FBD, this one is first FBD. Okay, first FBD, second FBD, third FBD. Okay, only third, only 3. Okay, if you use third FBD, you will get the answer that required to answer lah. Okay, alright, understand? Okay, so make sure that you choose the correct FBD to solve the problem. Okay, there are 3 possibilities. In this case, there are 3 possible FBD. Okay, like the previous one lah. Like the thing that we discussed. This, for example, this one lah. The easiest one. This one, sorry. This one. Okay. You can choose either one to solve the problem. You can choose B, C, D. You can choose B, A. Okay. You can choose the overall FBD like this. Okay. You can choose. There are 3 possibilities. Okay. The first one, the first FBD like this. The second FBD like this. The third FBD like this. Okay. And of course, the more complex one is this second FBD, where there are many unknowns value there. Okay. BX, BY, D lah, E lah, EX. So maybe this one is given. Okay. And in this case, maybe this one is the easiest way. Okay. For example. Okay. Same goes to this FBD example too. Okay. There are many possibilities. Okay. There are many possibilities of FBD. Okay. You can draw the overall. Okay, like this. You can select the specific member like this, and like this. Okay. Okay, to solve the problem. Okay. So for this exercise 1, sorry, example 1, exercise 1. Okay, there are 3 possible FBD that I showed to you just now. You have to choose the easiest one. Okay. In this case, the easiest one is third FBD. All right. So far, so good. Any question? Okay, so I believe that you understand already on how to choose the FBD. Okay, on how to choose FBD. So once you have the third FBD, you can see that there are 4 unknowns. Okay, there are 4 unknowns in this system. Okay, there are 4 unknowns. AY first, AX, the second unknown, the third unknown is DY, and the fourth unknown is DX. So if you have 4 unknowns, meaning that how many equations that you have to establish? How many equations?
4.
Yes, 4. 4. If 4 unknown, you have to introduce 4 equations. You have to find out what is the 4 equation. Okay. If the system having 4 equations, it's also tedious work. It is also tedious work. The best way, the easiest way is 2, 3 equation. 2 is the easiest way. Okay. Hussein just now asking about no moment. This one is not. What do you mean no moment, Hussein? Hussein, what do you mean by no moment?
Doctor, I think he means when we start to solve, there is no moment, equilibrium for moment.
Actually, the thing that I explained just now is about the equation, not equilibrium system. Okay, the system, the equation. Okay, the equation. Okay, maybe just recap back the previous example. I think this one is the best. No, this one. No, this one. No, this one. Let me check. Is there any previous example? No. Okay. The equation that I mentioned to you is not the force, not the moment. Okay, not the force, not the moment. The equation that I mentioned to you is the number equation that must be included in your calculation. Okay, must be included in your calculation. Okay. For example, the equation can get it from the equilibrium system, which is F equal to 0, moment equal to 0. Okay. So this is the thing that I have to show you. Maybe I show you in this example lah, how many equations that we have. Okay, maybe in after this lecture, we do have another lecture. I will show you. I will explain you about the equation. Okay, how many equation that you normally establish from the f equal to 0 and moment equal to 0. Okay. Okay, Hussein. Later on, I will explain to you. Okay, and of course we will use moment lah. Of course we will use moment equal to 0 and f equal to 0 to get the solution, to get the answer. Okay, back to this one. So same FBD, okay, with 4 unknowns, same FBD. This is your FBD, the completed FBD with dimension, with reaction, okay, with the geometry, okay, okay. So if you can see this one, you will know that 4 unknowns is there. Okay, ax, ay, dx, and dy, and this is tedious work. Okay, all right. So to make the work is easy, okay, you have to use 2 force member to eliminate 1 unknown. So if you eliminate 1 unknown, you will have only 3 unknowns. So this is the easiest work rather than you have to solve 4 unknowns. Okay, rather than you have to solve 4 unknowns, you eliminate 1, so you only have 3. Okay, so how to eliminate 1? We use 2 force member. This one, we introduce force. At the beginning, there is no forces at all, but to eliminate the unknown, we introduce, and the introduction of forces must be in equilibrium system. Okay, right. So how to introduce? Okay, the best segment, the best member to introduce a force, a 2 force member, is this member. Okay, is this member. Okay, so in this case, the best member to have 2 force member is member BD. Okay, because we do have this point and we do have this point. Okay, all right. So you cannot choose A, B, C. You cannot choose A, B, C. It is difficult, and it is not straightforward like BD. Okay, all right. So in order to introduce that, okay, you have to do the 2 force member lah. Okay, so let's say I'm doing compression. Compression. So at point D, we do have this one. This must be in line. This is the line AB. Okay. So this one, I put it D, for example. Okay. And then if I introduce D, so this one should be another force that cancel out the D, which is B. Okay. Sorry, I don't want to put D lah. I put another one to avoid confusing, because D is already there, dx and dy. So I put x lah, x. Okay, I put x. Okay, this one is x as well. Okay, to cancel each other. Okay. So if you have this one, okay, bear in mind that I draw the x force is only for the dB, for the BD. For the overall, this one is not included. Okay, for overall, this one is not included. Okay, once I have this system, once I have these 2 force member, okay, for the BD, I can use this x force, okay, where to replace dy and dx. Okay, where the x, okay, equal to dx square plus dy square root. Okay, all right. So x is actually, from this system, x is actually d. Okay, because this one is d. Okay, so I can replace x equal to d. Okay, this x equal to d. Okay, That's why in the beginning I put just straightforward D. So I changed to avoid confusing to make more explanation about it. I put it X. Okay, in the beginning it's X, but later on it will become D because the existing of dx and dy. Okay, so again, if I if I draw the overall system without having the dB, okay, there is no more x here. There is no more x here. So the remaining one is only x. Okay, the remaining one is only x or d. Okay, here. Okay, all right. So from here, once you have this x dx square plus dy square in square root, so you will not have, you will eliminate these two unknown. Okay, the remaining unknown is only d here. Okay, and the remaining unknown is ax and ay. Okay, so after you use two force member, from 4 unknowns, it will become 3 unknowns. Okay, it will become 3 unknowns like this. Okay, it will become 3 unknowns like this. Okay, so in this screen, okay, you can see the force is FBD. It's not fixed. I mean the F is not fixed. It depends on you. You can put D, you can put X, you can put you can put anything that represent the force. Okay, in my case I put D lah. In my case I put D, and the end of the day you will get the answer, the same answer. Okay, okay. In this example also, the direction is different from me. Okay, it is not really different, because later on if you get negative answer, you will get the correct direction later on. Okay, okay, it depends on you. It is depend on you. It is very subjective. If you want to do the compression, you can do like me. If you want to do tension, you can do like this one. Okay, I give you 2 example. Okay, okay, back to the slide. Once you use 2 force member, then from 4 unknowns, the system will have 3 unknowns only. Okay, like shown in this one. Ax, Ay, and FBD only 3 unknowns. From here, you can get easiest way to solve the problem. Okay, all right. Any question? Any question before I proceed? Okay, no. If no, once you have the completed FBD like this, you can solve it. Okay, you can solve it. Okay, all right, you can solve it. Okay, yes, the theta can get it from the triangle there, where the answer is given here. Okay, and from here you can use moment equal to 0, f equal to 0 to get the value of ax, ay, and fbd. Okay, from here, what is the next step to do the calculation? Is it moment? Is it force? What point you should take? Anyone? You can share. Anyone? Yes! Huh? Sorry? Tak dengar?
Moment at A, Doktor.
Yeah, correct. Thank you, Daniel, and thank you, Nur Akila. Yes, as I mentioned in the previous class, the moment is easiest way, number 1. Number 2 is you have to take a moment about point that eliminate a larger number of unknown. Okay, so in this case, point A is the largest number unknowns. Point A have 2 unknowns. So you can take a moment about point A first. Then straightforward, you will get the value of FBD. Okay, you will get the value of FBD in your calculation. Okay, so you solve the moment first, moment about point A. Okay, so this is the solution. Okay, moment about point A must be equal to 0. Okay, in this case, we assume clockwise is positive. Okay, so any clockwise will be in positive value. Okay, taking 100 Newton. Okay, perpendicular distance is 0.7, so plus 100 Newton times 0.7. Okay, and then FBD. Okay, FBD here. Okay, so you can actually resolve the FBD into this component. Okay, FBD cos theta. This one is FBD sine theta. So of course, FBD sine theta will not use it because there is no perpendicular distance. Okay, there is no perpendicular distance. Okay, from A. Okay, all right. So we do have FBD cos theta time with the perpendicular distance, which is 0.3. Okay, so FBD cos theta time with 0.3 and must be equal to 0. Okay, and you will get the answer of the FBD straightforward, this one. Okay, that's it. All right, once you have the FBD, you can get the AX and AY, the reaction at A. Okay, using equivalent system for the X component. You can choose either one lah. If you want to solve X component first, go ahead. If you want to choose Fy component first, go ahead. Okay, because in this case, you can choose either one. You can choose either one. Okay, so Fs equal to 0. Okay, we assume that positive should be upwards. Okay, and we determine Ax. Okay, Ax is positive. Sorry. This one is X. Positive should be right lah. Okay. And then Ax positive. And then we do have this component should be minus FBD cos theta. Okay. So substitute the value, you will get the answer of Ax. Okay. For Fy, upward is positive. Okay. Positive this one. Okay. Negative 100. Okay. And then this component minus FBD sine theta. Okay. Positive. Negative. It should be minus lah, this one should be minus. It should be minus. This one should be minus. Oops. Should be minus. And please check the answer, is it same or not? Please check the answer. I don't have the calculator right now. Please help me to check the answer.
Doctor,
Yeah.
there's minus.
Sorry?
The minus is there.
The minus,
Fy.
this one, right?
Minus 200. Yes, there is minus.
This one is original one. Same
Oh,
as to this
another
one.
minus.
Doctor, it will be
Okay.
75, but
Okay.
positive 75, not negative.
Which one?
AY.
AY is positive, yes. What do you mean? Is it the answer for the AY is positive?
Right, same answer, but positive, not negative.
Okay, so if you use this minus, okay, this minus, you will get AY equal to positive 75. Is it?
Yes, doctor.
Okay, all right. Okay, so please use this one. Please use this one, because there is error here. Should be minus. This should be minus. Okay. Okay. So once you have the AX and AY, you can get the magnitude of A using this equation. Okay. you will get the value of A there. Okay. So you can determine beta, which is the angle for the reaction force. Okay. So point A here, let's say point A here. Okay. And the value of AX is negative. AX is negative this way lah. Okay. AY positive this way. Okay. All right. This one is AX, AY. Okay. Because AY is positive. Okay, you can know the angle is from, this is your A. Oops, you can know the angle is here. Okay, the beta is here. Okay, the beta is here. Okay, so make sure that you draw this one as well in your solution. Okay, so you will know where is the angle, where is the magnitude of reaction. Okay, this is your answer. This is your fun answer. Okay. Okay, if you want to check your answer, is it correct or not, in this way, in this way, okay, where the AY is upward, AX is left, you can check again from the beginning. Okay, you have this system having this force, you can imagine that this system will be going downward like this, like this, like this, like this. So I fix at point A, my right finger actually, okay, okay. So it will be downward. So we can know, we can imagine that at point A is actually the reaction that opposes back to this force, okay, must be like this way lah, to maintain its equilibrium system. Because of this one. So we can imagine like that. Okay. So imagination is one way. It's another way to check the answer. To check the answer. Okay. So far, any question before we take a rest?
No, Doctor.
No. Okay. 5 minutes break. Is it okay?
Okay, Doctor.
Okay. We have 5 minutes break. Okay. 5 minutes only. Yeah. So I will continue with the next lecture later on. Okay. 5 minutes break.